A step-by-step walkthrough of the AQA 2019 AS Level Maths Paper 1, which is Pure Maths and Mechanics. It's quite tricky, we're going to have some fun, and let's do this. Hey there guys, welcome back to the channel. If this is your first time here, and you're trying to get the best grade in maths you possibly can, let me help. Start now by subscribing. Okay then, first up, state the number of solutions to the equation tan of 4 theta is equal to 1 for theta between 0 and 180 degrees. Okay, tan of theta has a period of 180, so tan of theta equals 1, it would have one solution. Tan of 4 theta happens 4 times faster, so there are 4 solutions. Number 2, Dan believes that for every positive integer value of n, at least one of 2 to the n minus 1 or 2 to the n plus 1 is prime, which value of n shown below gives a counterexample to Dan's belief. So we need one of these values of n to make this not work. So when n is 3, 2 to the power of 3 minus 1 is 7, so that's prime, that works. When n is 4, 2 to the 4 minus 1 is 15, which is not prime, but 2 to the 4 add 1 is 17, which is prime. 2 to the power 5 is 32, minus 1 is 31, that's prime, that works. 2 to the power 6 is 64, minus 1 is 63, not prime. 64 add 1, 65, also not prime. N is 6 is our guy. Okay then, number 3, so we have some factor theorem fun. So it is given that x plus 1 and x minus 3 are two factors of f of x, where f of x is px cubed minus 3x squared minus 8x add q. Part A, find the values of p and q. Okay, so by the factor theorem, because x plus 1 is a factor, f of minus 1 is equal to 0. And because x plus 3 is a factor, f of 3 is equal to 0. Okay, so what we're going to do is find each of these, get two equations in terms of p and q, and then solve simultaneously. So f of minus 1 well, that's going to give us minus p minus 3 add 8 add q is equal to 0. So minus 3 add 8 is 5. So from that we can get minus p add q is equal to minus 5. Okay, then we're going to find f of 3. So f of 3 is going to be 27p minus 27 minus 24 add q and again we know that is equal to 0. So from this we can get 27p add q is equal to 51. Okay, so now we are playing with these two simultaneous equations. So let's call them 1 and 2. Now we can get rid of q by subtracting one from the other. So I'm going to do 2 minus 1. So we are going to get 28p is equal to 56. That means then p is 2. Now we also know that minus p add q is minus 5. So minus 2 add q is minus 5. Therefore, q is minus 3. Okay, and then part B says to fully factorise f of x. So we now know f of x is 2x cubed minus 3x squared minus 8x minus 3. Now we also know that we can write f of x as x minus 1, x plus 1 times x minus 3 times another linear factor, which we're going to call ax and b. Now from that, if we multiplied this all out, we know we would get ax cubed, which means that a is going to have to be 2. And if we multiply the numbers, we're going to get 1 times minus 3, which is minus 3, times b, and that needs to be minus 3. So, b is just 1. So, finally, f of x is equal to, so I'm going to write it as x minus 3 times x add 1 times 2x add 1. Okay, number 4, we want to show that root 6 over root 3 minus root 2 can be expressed in the form m root n add n root m, where m and n are integers. Fully justify your answer, so don't just smash it into your calculator. So what we need to do is rationalise the denominator. Now the trick with a 2-term denominator is to use the difference of two squares. So we have root 6 over root 3 minus root 2. So we multiply top and bottom by root 3 and root 2. So on the top, root 6 root 3 is root 18. Root 6 root 2 is 12. Root 12. Now on the bottom you get first term squared minus second term squared, so that's just 3 minus 2, which is 1. So now we just need to simplify each of these surds. So root 18 is root 9 root 2, so 3 root 2. And root 12 is root 4 root 3, which is 2 root 3. Number 5a wants us to sketch y equals g of x, where g of x is x plus 2 times x minus 1 squared. Okay, so it's going to be a cubic. Now the x cubed term is positive, so let's write that down. So we have a positive x cubed term. So that means the graph starts in the bottom left and goes off in the top right. Now we need to find the roots. So for the roots, x plus 2 times x minus 1 squared is equal to 0. Now we're going to get a distinct root at x equals minus 2. So that means the graph crosses the x-axis at minus 2, and we get a repeated root at x equals 1, because that bracket is squared. Now at a repeated root, the graph only touches the x-axis but doesn't cross. So our graph is going to look something like this. So the x coordinate here is minus 2, and over here we have 1. Now for the y-intercept, we know that we have x plus 2 times x minus 1 times x minus 1. Now the y-intercept is the constant term, so the constant term would be 2 times minus 1 times minus 1. So the y-intercept is at 2. So, and the value in there is 2. Okay, we should also be good mathematicians and label our graph. So, y is equal to g of x. Cool. Okay, and then part B says, hence solve g of x is less than or equal to 0. So, that means we want the x values that make the graph 0 or less. So, we want all of this part of the graph, so that's, and we also were allowed to equal 0. So we also want x is minus 2. So the solution over here is going to be x is less than or equal to minus 2. Now there's also one particular value of x, which is here, where the graph is 0. So that is at x equals 1. So our two solutions are x is less than or equal to minus 2 and x is equal to 1. Okay, number 6, trigonometry time. So part A, part 1, show that cos of theta is equal to 1/2 is one solution to the equation. 6 sine squared theta add 5 cos theta is equal to 7. Okay, so with trig equations, we want to always get them in terms of one function. So here we want to get rid of sine squared. So we know that sine squared add cos squared is equal to 1. So sine squared is 1 minus cos squared. So then we can rewrite the equation as 6 lots of 1 minus cos squared add 5 cos theta Now because this is quadratic, we want everything on the same side, so I'm going to bring the 7 over to the left, so we get minus 7 is equal to 0. Okay, so we get 6 minus 6 cos squared add 5 cos minus 7 is equal to 0. So we have minus 6 cos squared add 5 cos minus 1 is equal to 0. Now we don't really want a negative squared term, so multiply through by minus 1, and we get 6 cos squared minus 5 cos, and 1 is equal to 0. And then we can factorise that to 2 cos theta and minus 1 times 3 cos theta minus 1 is equal to 0. So then our two solutions are cos of theta is equal to a half and cos of theta is equal to 1/3. Okay, then part B says, A part 2, find the values of theta that solve the equation for theta between 0 and 360 degrees. Give your answers to the nearest degree. Okay, so let's first of all deal with cos of theta is equal to 1/2. So if we inverse cos of 1/2, we get 60 degrees. Now we're also going to get another one. So remember, cos looks like that. So there is our 60. There's another one over here, which is going to be 60 back from 360, so the other one is 300 degrees. Okay, and then we need to do cos of theta is equal to 1/3. So if we inverse cos 1/3, we are going to get to the nearest degree we get 70.5, so that's 71 degrees. Now again, that gives us the value over on the left, so we also need to get the one over there, which is going to be 360 minus 71, so that's going to be 289 degrees. Okay, then for part B, let's find all the solutions of the equation 6 sine squared 2 theta add 5 cos 2 theta is equal to 7. For theta between 0 and 360 degrees. Give all your answers to the nearest degree. Okay, so probably the easiest way to explain this, I think the way people prefer, is to change the graph. So cos of 2 theta gets squashed together, so we now get two periods in 360 degrees. So we're now dealing with that, where this is 360 degrees. Okay. So, what we've now got, and the difference now, is that we've now got cos of 2 theta is a half and a third. So if we inverse cos, we will get 2 theta is 60 degrees. So theta is 30. Now that is going to give us this first chap here. Now this one over here is then going to be 30 degrees back from 180 degrees. So this one is now going to be 150. Now there's going to be 2 more. Now we know the period is now 180 degrees. So to count the other 2, we add 180 onto these. So 30 and 180 is 210. And 150 and 180 would be 330. So that's given us the 2 solutions here and over here. Okay, and then we also have cos 2 theta is a third. So that is going to, again, if we carry on from our values from part A, 2 theta would be 71 degrees, which, if we divide by 2 and round to the nearest degree, we would get 36 degrees. So that gives us the first one back here. So the second one is then 36 degrees back from 180, so that's going to give us 144. And then again, to get the next pair, add 180 to each of these. So we're going to get 216 and 324. 7, a nice 6 marker with binomial expansion. So given that y is an element of the reals, prove that 2 add 3y to the power 4 add to minus 3y to the power 4 is greater than or equal to 32. Fully justify your answer. Okay, so what we're going to do is do both of these expansions and hope something good happens. So you are given the binomial expansion formula To be honest, with small powers like 4, I think it complicates things. So I'm going to do this using the pattern. The formula sheet there is linked down below for anyone that wants it. So, the first thing we need for the expansion are the coefficients. So to get them, I'm just going to use Pascal's triangle. So the 1 on top is the 0th row. We need the 4th row. So there's the first, second, third, and then the 4th. 1, 4, 6, 4, 1. So let's expand to add 3y to the 4. Okay, so first term, the coefficient is 1. Now we get 2 to the power of 4, and then 3y all to the power of 0. So that's just 2 to the power 4. Now for the next term, our coefficient is 4. And then we get 2 to the power 3. And then 3y to the power 1. Next term, coefficient is 6. Now the power on 2 goes down, so we get 2 squared. The power on 3y goes up, so we get 3y squared. And the next term is then, well, the coefficient is 4. The power on 2 goes down, so we've now got 2 to the power 1. And then 3y cubed. And then the final term is just 3y to the power 4. Okay, so let's go through this. So 2 to the power 4 is 16. Now we have 4 times 8 times 3y. So 4 times 8 is 32 times 3y is going to give us 96y. Next term, we have 6 times 2 squared times 3y all squared. So that's 6 times 4, which is 24, times 9y squared. So that's 216y squared. Next time, we have 4 times 2 times 3y cubed, so that's 8 times 27y cubed, which is going to give us 216y cubed. And then the final term is 81y to the power 4. So that is the expansion of to add 3y to the power 4. Now Now we need to do exactly the same, but with 2 minus 3y to the power 4. Yay. Okay, so it's going to be very similar. There's just going to be some negatives. So we are going to get the first term is going to be the same. So 2 to the power 4. Second term is then going to be add. So our coefficient was 4 times 2 cubed times minus 3y to the power 1. So that's just minus 3y. Add 6 times 2 squared. 3y squared minus 3y squared add 4 times 2 times minus 3y cubed and then the final term is add minus 3y to the power 4. Okay, so again then, 2 to the power 4 is 16. We're then going to get 32 times minus 3y, so that's minus 96y. We're then going to get add 6 times 4 times 9y squared, so again that's 216y squared. And then we're going to get 8 times minus 27y cubed. So again that's minus 216y cubed. And then our final term, minus 3y to the power 4 is 81y to the 4. Okay, so now all we need to do is add the two greens together. Okay then, so from here we can now get an expression for the original sum. So to add 3y to the 4, add 2 minus 3y to the 4, okay, so we're going to add these two green expressions together. So 16 add 16 is 32. The y terms cancel. We're going to get 432y squared. And the y cube terms cancel. And then we're going to get 162y to the power 4. Now, if y is real, we know that y squared can be either 0 or positive, so can y to the power 4. So we should then say for real y, y squared is greater than or equal to 0, and y to the power 4 is greater than or equal to 0. So if y was 0, then the sum would be 32. For any other value of y, the answer is going to be greater than 32. So we've proven it. So therefore, add 2, add 3y to the 4, add 2 minus 3y to the 4 is indeed greater than or equal to 32. Number 8 is another nice 6 marker, so we want to prove that the curve with equation y equals 2x to the 5, add 5x to the 4, add 10x cubed minus 8 has only one stationary point stating its coordinates. Okay, so for 6 marks we need to be good and thorough in our working. So first of all, a stationary point is a point where the gradient is 0. So we should start by saying at a stationary point dy by dx is equal to 0. Okay, next let's find dy by dx. Okay, so we're going to get 10x to the power 4 add 20x cubed add 30x squared. Okay, so now we're going to set that equal to 0. So 10x to the 4 add 20x cubed add 30x squared is equal to 0. Okay, next, so we now want to try and solve this for x. Now there's a common factor of 10 running through, so we can divide that away. So we're going to get x to the power 4 add 2x cubed add 3x squared is equal to 0. Now there's also here a common factor of x squared. Don't divide that away because we're going to lose our coordinate that we want. Instead, factorise. So we can now write this as x squared times x squared add 2 add 3. So x squared add 2x add 3 is equal to 0. So what this tells us is there is at least one solution, which is x is equal to 0. from that x squared on the outside. So we can now write down there is at least one stationary point at x equals 0 so we can find the y coordinate of that point by substituting x into the original equation. And we can see from that when x is 0, y is going to be minus 8. So when x is 0, y is minus 8. So there is a stationary point at 0, minus 8. Okay, what we now need to do is prove there are no other stationary points. So, to do that, we need to prove that the quadratic x squared add 2x add 3 has no real roots. So, 4x squared add 2x add 3 equals 0. So to test whether this has roots, we're going to use the discriminant. So that's b squared minus 4ac. So for there to be no real roots, we need the discriminant to be less than 0. So that's going to be 2 squared minus 4 times 1 times 3, so that's minus 12. So that's going to be minus 8. So that means x squared add 2x add 3 has no real roots. Therefore, 0 minus 8 is the only stationary point. Nine A. So we are told a curve cuts the x-axis at to 0 and has gradient function dy by dx is 24 over x cubed. Find the equation of the curve. Okay, so we know that y is the integral of the gradient function with respect to x. Now, 24 over x cubed is 24x to the minus 3. So we need to find the integral of 24x to the minus 3 with respect to x. Okay, now this is going to give us, so the power on x goes up by 1 to minus 2, and we divide by the new power. So we get 24x to the minus 2 divided by minus 2 Now it's an indefinite integral, so we need the plus c. Okay, now 24 over minus 2 is minus 12. X to the minus 2 means 1 over x squared. So we can say y is minus 12 over x squared plus c. So now we need to find c. To do that, we need a set of coordinates on the line curve, which is good because we were told we hit the x-axis at 2, 0. So we know when x is 2, y is 0. So sub those in, we get 0. Is equal to 12 over 4, sorry, minus 12 over 4, so minus 3 add c. Therefore, c is 3. And then finally, y is minus 12 over x squared plus 3. And 9b, another 6 marker, so we want to show that the perpendicular bisector of the line joining A, minus 2, 8 to B, minus 6, minus 4, is the normal to the curve at 2, 0. Okay, so first up we're going to find the equation of this perpendicular bisector. So a bisector is a line that cuts through the midpoint of another line. And as it's perpendicular, the gradient is going to be perpendicular to AB. So let's find the perpendicular bisector first. Okay, so for this we're going to need the midpoint of AB. So let's find that. So midpoints are the mean coordinates of the ends. So the x-coordinate is minus 2 minus 6 divided by 2. So that's minus 4. And the y-coordinate is going to be 8 minus 4 divided by 2. So that's 2. Okay, now we're also going to need the gradient of the perpendicular bisector. To get that, we're going to need to find the gradient of AB. So, gradient is difference in y over difference in x. So I'm going to do minus 4 minus 8. So that's going to give us minus 12 over minus 6 minus minus 2. So that's going to be minus 4. Now that gives us 3. Okay, now the gradient of the perpendicular bisector is going to be the negative reciprocal of that. So the gradient of the bisector is going to be negative 1/3. Now we can use y equals mx plus c. So the equation is going to be y equals minus a third x add c Now we need to find c. To do that, we sub in coordinates of a point we know lies on the line. So that is the midpoint of AB. So we know when x is minus 4, y is 2. So that gives us 2 is 4/3 add c. Take away the 4/3, we're then doing 6/3 minus 4/3, we get 2/3. So c is 2/3. So then finally we get y is minus a third x. Add 2/3. So what we now need to do is show that is the same as the normal to the curve at point 2, 0. So okay, so for the normal, a normal has a perpendicular gradient to the curve at the point. So the gradient function, remember we know is dy by dx, was 24 over x cubed. So the gradient of the curve at 2, 0 is 24 over 8, which is 3. So the gradient of the normal is minus 1/3. Okay, use y equals mx add c again. So now we know y is minus a third x add c. Now at 2, 0, x is 2, y 0. So we get 0 is minus 2/3 add c. Therefore, c is 2/3. So the normal is indeed the same. It's y is minus a third x add 2/3. Boom. Okay, number 10. On the 18th of March 2019, there were 12 hours of daylight in Inverness. On the 16th of June 2019, 90 days later, there will be 18 hours of daylight in Inverness. Jude decides to model the number of hours of daylight in Inverness n by the formula n equals a add b sine t, where t is the number of days after the 18th of March 2019. Part A, Part 1, state the value scheduled for A. Okay, so n will equal A when the sine term is 0. Sine of 0 is 0, so A is the initial value, so it's 12. Okay, then in part 2, state the value scheduled for B. Okay, so we know 90 days later, n is 18. Now that happens when t is 90. Sine of 90 is 1. So we're going to get 18 is 12, add b, so b is 6. Okay, then for part 3, using Jude's model, we want to calculate the number of hours of daylight in Inverness on the 15th of May 2019, 58 days after the 18th of March 2019. Okay, so we're just substituting t equals 58 into n is equal to 12, add 6 sine 58, which to one decimal place is going to give us 17.1 hours. Okay, then for part A, part 4, using Jude's model, find how many days during 2019 we'll have at least 17.4 hours of daylight in Inverness. So, we can think of this as an inequality. We want 12 add 6 sine t to be at least 17.4. So greater than or equal to 17.4. So what's going to happen, we're all used to this daylight thing, as time increases from March, you get more and more daylight each day up until mid-June, and then daylight starts decreasing. So what we're going to do is solve this inequality and find the number of days it takes to get up to 17.4 hours. After that, it's going to increase and then start decreasing again. So we're going to need to find the second solution for 17.4. So, if we take away 12, 6 sine t is greater than or equal to 5.4. And then divide by 6, sine of t is greater than or equal to 0.9. Okay, so what we now want to find is where does sine of t equal 0.9. Now, if we inverse sine, we get 64.15, so t is 64. Now, if we draw a graph of this, we're only really interested in that bit. So 0.9 So our 64 is here. Now what we need is that guy over there. Now that's going to be 180 minus 64. So 180 minus 64 is 116. So this tells us the first time we have 17.4 hours of daylight is 64 days after, whenever we were in March. So we want the 64th day. Hours of daylight then increases up to the maximum, and then the last time we get 17.4 hours is on the 116th day. So what we don't want are the first 63 days. So our number of days is 116 minus 63, which is 53 days. Okay, then for B part 1, we want to explain why Jude's model will become inaccurate for 2020 and future years. So, trigonometry works on degrees. Sine has a period of 360. So, given that t is the number of days after when we started in March, Jude's model repeats itself every 360 days, but there's 365 days in a year. So that would be the answer to part 1. And then for part 2, Anissa decides to model the number of hours of daylight in Inverness using n equals a add b sine 360 over 365 t. We want to explain why Anissa's model is better than Jude's model. Okay, so by having that 365 on the bottom and the 360 on top, Anissa's model is actually now going to repeat itself every 365 days, so it's going to keep in time with the years passing. Then number 11 and the start of the mechanics. So a ball moves in a straight line and passes through the fixed points A and B, which are 0.5 meters apart. The ball is moving with a constant acceleration of 0.39 meters per second squared in the direction AB. The speed of the ball at A is 1.9 meters. We want to find the speed of the ball at B. Okay, so what do we know? We know S, U, A, and we want to find V. So the Suvat equation we are going to use is V squared equals U squared add 2AS. Now from that we can get that V is the square root of 1.9 squared add 2 times 0.39 times 0.5, and that gives us 2. So the answer is 2 meters per second. Case number 12, a particle P of mass m kilograms is attached to one end of a light inextensible string. The other end of the string is held at fixed position O. We are told P hangs freely vertically below O. Basically, tick the correct statement. So first up, T varies along the string with greatest value at O. So if you're taking your string to be light, tension is constant. So that rules out the second one as well. Third one, T is 0 because the system is in equilibrium. No, T is keeping the particle up. So it must be the last one. T is directly proportional to m. Of course it is. As the mass of the particle varies, it takes a bigger upward force, which is tension, to keep the particle up. So that's all going. Okay, number 13. A car starting from rest is driven along a horizontal track. The velocity of the car, v meters per second, at time t seconds, is modelled by the equation v is equal to 0.48 t squared minus 0.024 t cubed for t between 0 and 15. Part A wants us to find the distance the car travelled during the first 10 seconds of its journey. Okay, so to be able to do that, we are going to need to find the displacement function. Now velocity is the rate of change of displacement, so it's the derivative. S then is the integral of velocity. So S is the integral of uh, 0.48 t squared minus 0.024 t cubed with respect to t. Okay, so for that, we are now going to get 0.48 t cubed over 3, so that's 0.16 t cubed minus 0.024 t to the power 4 divided by 4. So that's going to be 0.006 t to the power 4. And then, of course, plus c. So, before we sub in t is equal to 10, we need to find the value of c. So we were told the car starts from rest. So that means when t is 0, we know that displacement is also 0, as was its velocity. So we know that when t is 0, S is 0, which means C is 0. Okay, so now we just need to find S when t is 10. So when t is 10, S is 0.16 times 1,000, so that's 160, minus 0.006 times 10,000, so that's minus 60. So that gives us 100 meters. And for part B, we want to find the maximum speed of the car, giving our answer to 3 sig figs. So, maximum speed happens when you've accelerated until you can't accelerate anymore. So, at our maximum speed, acceleration is equal to 0. Now, acceleration is the rate of change of velocity. So, to get acceleration, we need to differentiate velocity. So, if velocity was 0.48 t squared, minus 0.024 t cubed, then acceleration is the derivative of that, so 0.96 t minus 0.072 t squared. So again, at max speed, A is equal to 0, so that means then that 0.96 t minus 0.072 t squared is equal to 0. So if we factorise that, we get t times 0.96 minus 0.072 t is equal to 0. So we get two solutions. One, we knew t is 0. So that's at the start when we are at rest. Or t is 0.96 over 0.072. Which simplifies to 40 over 3. Or if you like, that's 13.3. Now remember what we're finding here, that is the time at which the maximum speed occurs, so that's seconds. So to find the maximum speed, we now need to put that time into the velocity function. So v of 13.3 should give you 28.4 meters per second. Okay then, for part C, we want to deduce the range of values of t for which the car is decelerating. Okay, so think about what we just did. We found the acceleration function, which was a quadratic. We found the 2 points where acceleration was 0. Now there was one at the start because we were at rest, and then the next one was when we were at our maximum speed. So after we are at our maximum speed, acceleration is going to be less than 0, so we are decelerating. Now acceleration was 0 at 13.3 seconds, so just after that we are decelerating. So t needs to be greater than 13.3, and this whole model was about the first 15 seconds of the journey. So we're going to be decelerating all the way up to and including 15 seconds. 14. Two particles A and B are at rest on a horizontal plane. Particle A has position vector 13i minus 22j meters, and B is 3i add 2j meters. Part A, calculate the distance between A and B. Okay, so the distance between two points in terms of vectors is the magnitude of the vector A to B. So our job is to find the magnitude of A to B. Okay, now A to B is the position vector of B minus the position vector of A. So RB minus RA. So we are going to get 3i minus 13i, so that's minus 10i. And then 2j minus 22j, so that's 24j. Okay, and then the magnitude is the square root of minus 10 squared, which is the same as 10 squared, add 24 squared, and you should get 26. And then I guess that would be meters. Okay, then for part B, we are told three forces F1, F2 and F3 are applied to particle A, where F1 is minus 2i add 4j newtons, F2 is 6i minus 10j newtons. Given that A remains at rest, explain why F3 is minus 4i add 6j newtons. Okay, so particle A then is still in equilibrium, so for equilibrium f1 add f2 add f3 must be 0. Now, if we add f1 and f2 together, we are going to get 4i and then minus 6j. Add f3 is 0. So, move the vector components over to the right and we get f3 is indeed minus 4i add 6j. Okay, then for part C, we are told a force of 5i minus 12j newtons is applied to particle B so that it moves from rest in a straight line towards A. B has a mass of 0.8 kilograms. Part 1, show that the acceleration of B towards A is 16.25 meters per second squared. Okay, so for this, we're going to need force is mass times acceleration. Okay, now we need to work out the size of the force. So the force is the magnitude of 5i minus 12j. So that's the square root of 5 squared add 12 squared. Which is going to give us 13. So we now have 13 is 0.8a divided by 0.8. A is indeed 16.25 meters per second squared. Okay, then for part 2, hence find the time taken for B to reach A, giving your answer to 2 sig figs. Okay, so let's think about what we know. We know the distance between them, S, is 26. U is 0 because both particles start at rest. We don't know V, we know A is 16.25 and T is the guy we are looking for. So, it's a job for Suvat, and the one we are going to use is S is equal to UT add 1/2 AT squared. So, using that, we get 26. UT disappears because U is 0, so we get add 16.25 over 2 t squared. 16.25 over 2 is 8.125. So divide through by that and square root, we get t is root 26 over 0.125, which gives us 1.788 blah 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 to 2 sig figs, which is 1.8 seconds. 15. Final question. So a tractor and its driver have a combined mass of m kilograms. The tractor is towing a trailer of mass 4m kilograms in a straight line along a horizontal road. The tractor and trailer are connected by a horizontal tow bar modelled as a light rigid rod. Now, because of that, we are able to model the system as a single particle. We are told a driving force of 11,080 newtons and a total resistant force of 160 newtons act on the tractor. A total resistance force of 600 newtons acts on the trailer. We are told the tractor and the trailer have an acceleration of 0.8 meters per second squared. Part A, find m. Okay, so as I said, because they are because they are connected by this rigid rod, we can model them as a single particle. So the total mass is 5m. Now the resultant force is the driving force minus the two resistant forces. So 11,080 minus 600 and minus 160, so minus 760. Now that gives us 10,320 newtons. Okay, now using F equals ma, we get 10,320 is equal to 5m times 0.8. Now that, well, let's do it properly. So 5m times 0.8. Now that's 4m. So 4m is 10,320. And this is kilograms. So divide by 4 and we get m is 2,580 kilograms. But we want to find the tension in the tow bar. So if we now look at the trailer on its own, then let's make a really good drawing. Okay, there's our trailer. Now, if we're moving off to the right, let's say we got the rod there connecting to the tractor. Now tension is pulling the trailer to the right. So tension is acting that way, and our resistant force is 600 newtons. Now we know the mass of the trailer was 4m, so the mass is 4 times 2,580, which is 10,320. Now again, using for F equals ma, we know that the force, or the resultant force, is tension minus 600. Now we know that same force is mass times acceleration, so 10,320 times 0.8. So T minus 600 is equal to 8,256. So add the 600, T is 8856 newtons. Okay, then for the final part, a bit of a tricky one. So at the instant the speed of the tractor reaches 18 kilometers per hour, the tow bar breaks. The total resistant force acting on the trailer remains constant. We want to, starting from the instant the tow bar breaks, calculate the time taken until the speed of the trailer reduces to 9 kilometers per hour. Okay, so what do we know there? We know the initial speed and the final speed, except they are in kilometers per hour. So first thing I'm going to do is convert each of those into meters per second. So 18,000 meters per hour to turn that into meters per second, we need to divide by 60 to get meters per minute, and then again to get meters per second. So we're going to divide 18,000 by 3,600. Now that quite nicely gives us 5 meters per second. Okay, so we now know U is 5 and V is going to be half of that, so 2.5. Okay, so what would be really handy here is if we could work out the acceleration, and then we can use V is U add AT. Now, luckily we can work out the acceleration. We know the only force acting on the trailer is now the resistant force, which, because it's resistant, is going to be minus 600. So we know minus 600 is equal to the mass, so 8256, sorry, 10,320 times the acceleration. So acceleration is minus 600 over 10 320 which gives us, if we go to two sig figs, minus 0.058 meters per second squared. Okay, so now, again, we can use V is U add AT, so we get 2.5 is equal to 5 minus 0.058 T. Which we can rearrange to 0.058 T is equal to 2.5, and then divide by 0.058 and we get T is 43 seconds. Guys, that's the end of this paper. Really hope you found it useful. Paper 2 will also be here. If you're not already, make sure you get subscribed to the channel. I'll take you through A-level maths year 2 as well. For now, take it easy, take care.